Welcome back to the mission. In our last unit, we dominated the physical wall. You used bead mills and liquid nitrogen to turn your tissue into a uniform powder. But here is the specialist secret that technicians often miss. Breaking the house doesn't mean you've captured the residence. Physical force gets you through the front door, but the analytes are often still hiding in the basement. This unit, the chemical breach, is about the strategic decision-making required to unlock the molecular vault. By the end of this session, you won't just pick a buffer because it's in the fridge. You will pick it because it is the precise key for the lock you are trying to break. Have you ever spent days on perfect homogenization, only to find your final mass spec signal was non-existent? Even after physical smashing, your analytes, the gold, are often still trapped. They are chemically sticky. They are bound to proteins, hidden in lipid bilayers, and buried in microscopic debris. To get them out, we need more than force. We need a chemical breach. Think of this as a negotiation. We are using chemistry to convince the sample to let go of the truth. Let's learn how to open that safe. To master the chemical breach, we divide our arsenal into 4 strategic categories. First, the old guard, traditional buffers like NP40, RIPA, and SDS. Second, the secret sauce, additives like inhibitors that act as reinforcements. Third and fourth, we have the elite precision tools, FASP and S-Trap. Over the next few minutes, we will deep dive into each of these to see when to deploy them. A specialist never starts the breach without a plan for the cleanup. An average technician picks whatever buffer is closest. A specialist chooses based on the target's location. NP40 is the diplomat. It's mild and preserves function. RIPA is the gold standard. It's harsher and breaches the nuclei. But SDS is the nuclear option. It denatures everything instantly. However, there's a catch. SDS is a signal killer in MS. If you use it, you must have a plan to purge the evidence before it hits the instrument. A specialist architects the breach, knowing they have to clean up the mess later. A breach fails without reinforcements. The moment you lyse a cell, the cell's own enzymes wake up. They will eat your target proteins before you can measure them. You must add protease and phosphatase inhibitors immediately. Think of them as the bouncers who stop the cell from eating the evidence. Also, consider reducing agents like DTT. They ensures your analytes don't clump together. Remember, these reinforcements are unstable. Add them right before the breach. When you use the nuclear option of SDS, you need an elite system to clean it up. Meet FASP, the filter-aided sample prep. FASP repurposes ultrafiltration units as a, quote, proteomic reactor. You load your proteins onto a membrane, then use 8M urea to scrub away the detergent. The beauty of FASP is its versatility. You can perform consecutive digestions to maximize coverage. But FASP is a, quote, vintage elite tool. It is notoriously slow and prone to clogging. In high-throughput environments, we often need something faster. If FASP is the slow reactor, the S-Trap is the ultra-fast disruptor. Instead of a membrane, S-Trap uses acidified methanol to turn your proteins into a particulate suspension. Think of it as creating a chemical snowstorm inside the tube. This suspension is then trapped in a 3D porous glass filter. The results are game-changing. While FASP takes hours, S-Trap detergent removal takes 15 minutes. It yields more protein identifications and better reproducibility. In high-throughput clinical labs, the S-Trap is the specialist's weapon of choice. Let's put your knowledge into practice. Every specialist uses a decision matrix before they touch a pipette. Use this checklist. Functional analysis? Stick with the Diplomat NP40. Total proteome overview? Go with the nuclear option of SDS. But remember the cleanup plan. Do you have 2 days or 2 hours? If you have 2 hours, S-Trap is your answer. If you need maximum coverage, FASP remains a powerful choice. A pro never starts the breach without knowing exactly how they will clean up the mess. We have successfully completed the briefing for the chemical breach. We've learned that physical domination only gets you through the door. It's chemistry that lets you win the treasure. You now know the hierarchy of buffers and why inhibitors are your essential insurance policy. As we conclude, I want you to remember, chemistry should open the door, not be the bouncer. You have breached the cell and captured the analytes. You are now standing on the threshold of pure detection. You've mastered the breach, but if you are looking for small molecules, the proteins we just worked so hard to solubilize are now your biggest problem. They will foul your columns and hide your targets. We need to get rid of them, efficiently and completely. Join me in our next unit, Module 2 to 4, Crashing the Gate. We are going to master the art of protein precipitation to clear the final path for pure, small molecule detection. You've unlocked the vault. Now let's clear the debris.